Hi everybody, we're looking at chapter 2, section 4, and we are back in absolute values, especially as they apply to inequalities, which we like to call open sentences here in the world of math. Alright, so we're going to do a quick review of what absolute value means, then we're going to look at a couple of example problems, and then I'll send you on your way to try some on your own. Alright, so we're just looking now at absolute value here. We've been looking at absolute value for a while, and by a while I mean over the past many years. But we've probably been really relying on the basic surface level sort of answer or result with absolute value. Absolute value is positive, always positive, right? But we're probably not really diving deep into why that's true. So we're going to spend a moment here and think about why is absolute value always positive? Right, so I have this absolute value of x here, and I'm saying the absolute value of x is 1. Now what that means is that I'm looking at 0, and I am going from 0 a measure of 1 unit in either direction, right? So I'm just going to look, here's 0, I'm going 1 unit this way, and I land at positive 1. Alternatively, if I start at 0 and go 1 unit this way, I land at negative 1. So in other words, the absolute value of x equals 1 is saying that when I start at 0, travel a distance of 1 unit in either direction, then that gives me my two options for what x could be. So I might also say the distance between x and 0 equals 1. The solution being x equals negative 1 or x equals 1. Now we're looking at absolute value as it relates to inequalities. So here we have the absolute value of x is greater than 1. The way that I might read this to make it a little bit more clear what's going on is the distance between 0 and x is greater than 1 unit. The distance between 0 and x is greater than 1 unit. So I'm going over to my number line here, looking at 0, and then I'm moving again 1 unit to the right and 1 unit to the left. And those, though, that's where I start my answer. So I'm moving 1 unit to the right. So here is where I start my solution and my plug-in. And then I'm going to start at 0 again and move 1 unit to the left. And here's where I will start my solution set, right? So the distance between 0 and x is greater than 1 unit. Each of these is 1 unit. So my solution then is going to look like this. X is less than negative 1, or x is greater than 1. I'm just going to take a moment now to remind myself that this kind of sentence is an and, a conjunction, whereas this kind of sentence is an or a disjunction. Now, one of the first teachers that I worked with when I was learning how to teach had a little bit of a trick for remembering how to translate absolute value with an inequality into an or an and statement. Ideally, I'd really love for you to dive into this concept, but to get started, it might be helpful to have a little bit of a memory tool to help us out. So I'm going to make a chart. All right, so let's look for a moment at this chart. In the first column, I'm looking at the simplified form of this problem. In each of these examples that we looked at above, there's nothing to simplify. It's already down in its simplest form. So I just wrote in each different perspective here. Then in this column, I'm going to write out the sign. Here it's an equals, here it's a greater than sign, here it's a less than sign. Now, over here is where I'm going to write my final solution. I first wrote whether it's a disjunction or a conjunction, and then I just copied down the final solution. Now here's the trick. This is the part that I love. When I have a greater than sign, look at this. Look how I spelled it. Greater. Greater than. So greater thans have this or. And that's what we found up here as well. Less than, I wrote it, less than are conjunctions, the and, which is the same thing that we looked at graphically up here. Now, one of the important things to note is that when I'm looking at the simplified problem, I am looking specifically at the variable on the left and the constant on the right. Need to make sure that I'm talking about when I label as a greater and or less than, I need to be talking specifically what the variable is in relation to the constant. The variable is greater than the constant. The variable is less than the constant. In an effort to keep the length of these videos down and for them to be the most useful for you later, I like to spend time working on the more complex, or just one more layer of complex than what we generally look at in class, or what I would assign you to work on your own at this point. So what I'm going to do is I'm going to look through the written exercises rather than going over the examples specifically from your book, which, by the way, are on page 73 and 74. What I encourage you to do is pause the video, try to work each of the 3 examples on your own, then compare your solution to the solution in the book. After you do that, then return to the video, and we'll work some of the more complex ones from the written exercises together. All right, so now I'm looking at page 75, the written exercises. Specifically, I'm looking at number 15. Now, what I'm going to do is just real quickly I'm going to distill that chart that we worked on just a second ago down to these 2 quick phrases, greater, less than. I notice here that everything is simplified, meaning that there's nothing outside of the absolute value that I can move or rearrange in order to get the absolute value by itself. The absolute value is already by itself. Now, what I need to do is separate this out into 2 open sentences, 2 inequalities. What I notice is that the variable is greater than 0. It's greater than 0. But it's a little bit easy, or a little bit hard to read because I know that when I read this, it's a less than sign, the variable is on the right side instead of the left side. So if seeing that the variable is greater than 0, let's use the reflexive property and flip this thing around. So now I can see a little bit better that I've got the variable is greater than 0. So using my mnemonic, greater, I'm going to break this down into 2 statements that are combined by or. The first statement is simply taking the absolute value off and then writing this or. Now the next statement, I have to account for the negative or the opposite direction of this, what's inside the absolute value. So what I like to do is say negative, parentheses, what's inside here, and then leave the sign and leave the constant. Some people prefer, and I think the book shows you this, that rather than writing it that way, they'll tell you to leave this alone, but then flip the sign and negate the constant, which is totally valid. That's the same thing, that's really essentially the same thing that we're doing here. But for me, because I get left and right mixed up, I get numbers mixed up, remembering which way the sign needs to go and where the negative needs to go gets to be a little bit too much for my brain. So I like to think of the positive of what's inside the absolute value and the negative of what's inside the absolute value. Now just remember from class that we're going to solve each of these separately and then look at each of those solutions in order to determine what our solution should be. All right, so I've just solved each part of this problem, reduced it down so I have u is greater than or equal to 7/4. And then over here, distributing the negative sign, subtracting 7, dividing by that -4, which means I'm flipping the sign around. I see that u is also less than or equal to 7/4. So now I'm looking at my number line. I like to graph my thoughts above the number line before I put my solution set on the number line. So it's kind of like showing my work. So the first one I'm going to graph is this. I'm going to look at, let's see, 7/4. So I've got 0, 1, 2, 3, 4, 5, 6, 7/4. So I'm going to circle 7/4, shade it in, and u is bigger, so it's going to go in this direction. Now I'm going to look at this other solution over here. U is less than or equal to 7/4. Oh, lucky us, we already counted out the 7/4. So I'm just going to start here, shade it in, and then u is less than that value. What I notice is that I've got an or statement. Or means that I'm not worried about overlap. In fact, any number that's already shaded continues to be shaded in the solution set. And what I notice is this arrow goes forever in the negative direction. This arrow goes forever in the positive direction, and they start at the same value. So that means my solution set is the entire number line, right? Whenever something is the entire number line, it means that my solution is all real numbers. All right, so now I'm looking at, still page 75, looking at number 27, and I'm still in that one layer more complex of these problems. What I notice here is that I've got the absolute value on either side of the absolute value sign. I also have this stuff attached outside. So this is not in simplified form. I've got to reduce 7 plus 5 times the absolute value of c is less than, and then I've got to reduce 1 minus 3 times the absolute value of c. It's a 1, not an absolute value sign. All right, so the first thing I'm going to do is just simplify, decide which side of the absolute, or the inequality sign I want my constants to be on, which side I want my absolute value to be on. Now what I like about this here, negative 3c, is I can add it over to this side and have a positive coefficient. I'm going to subtract that 7 over here. All right, so let's look at that. All right, so I've simplified both sides, and now I have 8 times the absolute value of c is less than or equal to negative 6. I want to always treat absolute value as a grouping sign until I actually use it as absolute value. So what that means is I need to remove everything, including this 8, from the absolute value before I can get into looking at what's going on with c there. So I'm going to decide to, since 8 is multiplied by the absolute value, I'm going to divide it over on both sides. So the simplified form of my problem is the absolute value of c is less than or equal to negative 3 halves. I'm going to remember back to my mnemonic device here. I've got greater, and less than. Here, I've got a less than sign, variable, less than, constant. So I'm going to use this, less than, which means to me that I have a conjunction. So what I'm going to do with this is I'm going to rewrite. I'm just going to use some of the space over here. I'm going to rewrite this thing so that I have c is less than or equal to negative 3 halves, and negative c is less than or equal to negative 3 halves. All right, so now I'm going to look at these two sentences and see if I can't simplify a little bit more and then maybe even combine them. What I love about ands, or conjunctions, is that I can end up writing one long sentence instead of two separate ones. So what I notice here, I've got c less than or equal to negative 3 halves. There's really nothing I can do to make that more simple, but on this side over here, I'm going to just divide by negative 1 on both sides. So that leaves me with c, switching the sign because I'm dividing by a negative, is greater than or equal to the positive 3 halves. So now what I see is c is less than or equal to negative 3 halves, and c is greater than or equal to 3 halves. This is starting to seem a little strange, but I'm going to graph it just to see what's going on. All right, this first sentence here, I'm going to graph. So I'm going to look for negative 3 halves. So 1 half, 2 halves, 3 halves, negative 3 halves. Got a closed circle, and c is less than here. All right, now I'm going to look at the other sign, or the other open sentence here. I'm going to find 3 halves, positive 3 halves. So I go 1, 2, 3 halves, closed circle, and c is greater than this value. Okay, so I've got these two things going in opposite directions, but I've got a conjunction, got an and, which means that I'm looking for overlap. I notice here that I've got no overlap, none whatsoever. When I have no overlap, that means I have no solution. Since this is a conjunction, this is an and statement. No overlap means no solution. No solution. Remember that no solution could also be written as this symbol, kind of a zero-looking thing with a line through it, which means the null set. The last section in this unit that we're going to worry about covering is section 3 in chapter 2. It starts on page 69. And it's really just another word problem section. So we're going to take everything that we've been practicing in 1, 2, and 4 and apply it to word problems. We'll look at that in class.